topic that we're going to cover in here is actually just the general stuff. It's on page 677. It's just basic factors that determine blood pressure. And so what we're going to do, and I'm not monitoring the chat during this. Whoops, it's totally upside down. That's funny. What we're going to do is, there we go. I can't see the chat. So if you have a question or something, just unmute yourself and call out loud because I can't see if you're raising your hand or anything like that. So this is all factors that affect blood pressure. And when I do my notes and drawings, like personally, I do little things like this around it. It may seem a little extravagant to have extra little details like that. It's going to help you remember the words that are on the page. If it's more visually pleasing, it's going to be in your recall a little more. So just kind of keep that in mind. So there's three major factors that determine blood pressure, right? Our first major factor is what we call peripheral resistance. And if you haven't already started to figure out this word peripheral, it really just means outside the heart. Peripheral itself just means outside the heart. So this is the resistance that's happening outside of the heart within the blood vessels. That's one of the major themes of this chapter, is looking at how resistance is created, right? And things that kind of cause that resistance. So there's four major things that cause or kind of impact the resistance that is in the periphery around the heart. And just like I'm doing, maybe switching colors. I know it seems, again, a little childish, but switching colors, again, this visual cue will really help you with memorizing and studying. So one major factor in peripheral resistance is just the diameter or the radius of the vessel. So the vessel diameter, right? That's how open or closed our vessel is, right? If it's constricted or if it's dilated, right? Constricted means that it's smaller, dilated means that it's larger, right? And so a smaller vessel is going to increase the resistance. So I also do a lot of this where I will say if the diameter goes down, right? In other words, we have a small vessel, our resistance goes up, right? And if our peripheral resistance goes up, our blood pressure is going to go up, right? Our blood pressure is going to go up. And so having an idea of this relationship is really going to help you. So the reverse of this is true as well. If our diameter goes up, right, we dilate our vessels, our resistance goes down, and our blood pressure goes down. Whoops. I kind of messed up my arrows there. Sorry about that. So our blood pressure goes down. And that makes sense. When your vessels are relaxed, there's more room for the blood to flow through, and therefore it's not going to be as under so much pressure. So another major factor in regulating our blood pressure, or specifically our peripheral resistance, is going to be the viscosity of the blood. Viscosity is kind of like the thickness of the blood. So it's kind of how runny the blood is, how watered down the blood is. People that drink a lot of water and are very well hydrated are going to have a different blood viscosity than someone who is dehydrated, right? Someone who is dehydrated might not have as much blood volume, might not have as much plasma in their blood, and therefore will have a very viscous, thick blood compared to someone who has lots and lots of water in their system. So same thing here. We're going to kind of think about these factors and what they do to peripheral resistance, and then therefore how they affect blood pressure. If our viscosity goes up, in other words, we have a very thick blood, our resistance also goes up. And as resistance goes up, our blood pressure goes up. Okay, and then it's the reverse here. So this is what we call a positive relationship. If one goes up, the other goes up, right? If viscosity goes down, our resistance goes down and blood pressure goes down, right? So that's a good thing. The thinner our blood is, the lower our blood pressure can be. We also have the idea of blood vessel length. And again, I abbreviate a lot. BV, length, right? So we have long versus short, a long blood vessel. And this can also, you can also think of this as kind of the distance from the heart, or how far away something has to be in order to get to the destination, right? How long the vessel has to be. So vessel length is going to affect our blood vessel. Basically, the longer the blood vessel, the greater our resistance, right? If you think about it, our blood vessels are basically hallways, right? Basically hallways. As our blood flows through this really long hallway, and typically I would demonstrate this in lecture, you have to think about the blood rubbing up against all of this length of wall. That's going to increase the resistance. So the longer the length, as length goes up, our resistance goes up, and therefore blood pressure goes up. Right? So in other words, in order to get blood to pump all the way down to the toes or all the way up to the brain through very long blood vessels, in order to overcome that resistance, we have to have a relatively high blood pressure. So there's another positive relationship there. As the length goes down, our resistance goes down, and our blood pressure goes down. The shorter the blood vessel, the less resistance, the less pressure is needed to overcome that resistance. Okay? All right, the last major factor that influences our peripheral resistance is blood vessel obstructions. Right, so these are things like plaques in the arteries. This is buildup in the arteries. This is typically a result of your diet or a result of genetics in some cases. So these would just be obstructions. So we'll go back to this hallway analogy over here. Imagine that there's things in the way, right? Now our blood is going to be bumping up against these things, and it kind of swirls off of it, right? And bumps over here and kind of swirls off of it and bumps off of it and swirls and bumps and swirls. And so all of that is causing our blood flow to be obstructed. So if the amount of obstructions goes up, right, our resistance goes up, and therefore, you guessed it, our blood pressure goes up. So this is another positive relationship. As our obstructions go down, resistance go down, blood pressure also goes down. How are we doing? Good? I can't hear anything. Hopefully we're all there. Just clicking back, make sure I didn't leave. Okay. I'm going back to my thing here. Okay. Here we go. We're going to continue with factors that affect blood pressure. So, along with peripheral resistance, and again, I encourage you to be as swirly and artistic with this as possible. Go back through and make it all color-coded. It, again, sounds cheesy, but you get to the exam and you're like, I remember it was written in purple. It was in the middle of the page. What was it? Oh, yeah, obstructions, right? So we have cardiac output as our second major factor that affects blood pressure. And we know all about cardiac output from the last chapter, right? The cardiac output is the amount of blood being pumped out of the heart every single minute. It is a factor of two things, and these are the two things that we're going to kind of put on our chart here. We have heart rate, right? And we have stroke volume. Those are our two big players here when it comes to cardiac output. As our heart rate goes up, so if we think about increased heart rate, we go back over here, think about our blood vessel. We're pumping very, very quickly through our vessel. An increased heart rate is also going to increase blood pressure. So there's another positive relationship. As our heart rate goes down, our blood pressure goes down. And you know this when you relax, right? We've talked about sympathetic and parasympathetic output. And so this is, of course, our sympathetic, right? And this is parasympathetic. I know that's hard to see. It just says sympathetic and parasympathetic. And then, of course, stroke volume. This is the amount of blood that's actually leaving the heart. As our stroke volume goes up, our blood pressure goes up because there's more blood in the vessels. As our stroke volume goes down, our blood pressure goes down because there's less blood in the vessels. The amount of blood in the vessels is directly proportional to the blood pressure. So the more blood you have, the higher your pressure. The last piece of this, and that's a good segue, the last piece of understanding blood pressure is understanding blood volume. So blood volume. So we can regulate blood pressure by our peripheral resistance, by our cardiac output. This is all happening in the heart. So peripheral resistance, this is all in the vessels, right? This is all in the heart. And our blood volume is all in the blood, right? So here's our 3 chapters, right? This chart here is basically a summary of the physiology we've learned in all 3 chapters. Our blood volume is influenced by 2 major things, right? The amount of water coming in and the amount of water going out. And we're going to look at how that's regulated in this chapter also. So we call it water gain and water loss. And as you might suspect, if we increase the volume, we're increasing the pressure. So if we gain a lot of water, we're going to increase our blood pressure, right? And it's not just gain, it can also be retain water. Gain or retain, right? Hold on to water. And then same thing, water loss. We lose water. Lost water, my bad. Lose water. Our blood pressure is going to go down. Right? We get rid of water or we bring in less water, right? But like we said before, if you lose too much water, you don't have enough water, that's going to impact the viscosity, right? Which could have the opposite effect. So it ultimately is determined by lots of factors. It's not just one thing that's going to determine your blood pressure. So I'm going to stop